Good morning. Today we are going to see about the topic called survival analysis. It is also a field of statistics which is used to predict the occurrence and timing of events. An event is a process at which time it has been happened, so that we could observe all the things and we could notify the observation so that we could reach the meaningful conclusion. So here in case of statistics, the survival analysis is an method of studying of occurrence and the timing of events. An event is just something which happens which will produce one proper output. Here the survival analysis requires the researchers to find out the changes and the reason for the changes. So that censoring is a special tool which is used for doing survival analysis. We could observe each and every value for each and every amount of time. Then we could come to the conclusion that what is the situation. So here there are two different types of censoring. We are having so many types of censoring. The major category is left and right censoring. So as we know that censoring is the occurrence of that event is happen, and every time we are observing that, but at certain particular point of time we are leaving out the observation, so that is called censoring. So here we have the censoring. It occurs when we have some information about the individual but we do not the survival time exactly. So at that time we may miss that observation, so that is called censoring. So first type of censoring is right censoring. Here we know that the event of interest has happened only at the end of the particular point of time, but we know that event time it exceeds the certain value. Suppose we are considering a patient study time, we could have a certain follow up after the test is being recorded, but that follow up when we miss to find out how it is, or we miss to find the observation, then we could say that survival time is the time of lost contract or observation. So this is the right censoring. Then next left censoring means the event has been occurred priorly before the study, so that data will not be necessary for our study, so we just leave out all those data. So this is considered as a lower bound of test, so it is called left censoring. The next is interval censoring. Whenever a particular event is going to get happen at that particular time within the specific interval, we could have all the observations. So this is called interval censoring. The next is non-informative censoring. In case of non-informative censoring, we are suppose patient, if he left out the study due to any unrelated reason, we can say that it is non-informative. If it is informative, means due to some health issues he may leave out the study, so that we could have stopped our observation of monitoring the particular patient. So this is called non-informative censoring, and the next thing is called informative censoring. Here, as I have said already, it is that when knowledge is being imposed on patient, that is the reason for leaving out the study is known, we can say that as informating, but without any reason we are leaving out the study, we could say that as a non-informative censoring. In that same line, truncation also gets started up. Truncation means we are cutting out, that is we are removing out certain values from the entire data set. So here there are left and right truncation. So individuals whose event times are before the start of the observation. Before the observation, if anything has happened, means we could have, we may not monitor it, so that the left side data will get truncated off, and we could go for survival analysis only in the remaining part of data. Likewise, right truncation means the individuals whose event times occurs after a certain cutoff. We could have fixed up the upper boundary, and among that boundary only everyone is aware of it, and among that boundary only we are finding out the values. But if once the boundary gets expired and we are moving out of the boundary, we should have truncation of the right side data. So these are the various method of doing survival analysis. Thank you.